Alright, so I think this is recording. Let's solve this exponential equation. And you may immediately recognize that the bases that you want, here we have 1,000, here we have 100. The reason the metric system that students like it so much, it's based on powers of 10. You can see that 1,000 is 10 to the third power since there's 3 zeros. 100 is 10 to the second power because there's 2 zeros. So we can rewrite both of these sides as a power of 10. So on the left hand side I have 10 to the third power is how I'm going to write 1,000. That's being raised to the x minus 5. The 100, I can write it as 10 squared. And when you have a power to a power, you multiply the exponents. 3x minus 5. And I can make this 10 move up to the numerator if I make that positive 2 a negative 2. Now don't forget that that's still being raised to the x squared plus 3 power. And so it's a power to a power, so I need to multiply those exponents together. So I have negative 2x squared minus 6. Because exponential functions are one-to-one functions, if the numbers are the same and the bases are the same, the exponents must be the same. Let's get this quadratic equation in standard form. If I move the negative 2x squared to the other side and keep the 3x where it's at, and if I add 6 to each side, I get this set equal to 0. Now I may or may not be able to factor this. Quadratic formula completing the square will always work. Quadratic formula will always work. Let's see if we can factor it. The first term times the last term, and two numbers that multiply together to give us the top number but add together to give us the bottom number. So it does look like we're going to be able to factor this. Along one diagonal, we write the first term and last term from the original equation. And then along the other diagonal, we use the values that we found in our x from our trial and error. And it doesn't matter whether, you can switch the diagonals. That doesn't matter. When we look to see what's common horizontally here, they don't have anything in common. When we look vertically here, they just have the 1. Yeah, I forgot that x right there. I was trying to say, wait a minute, what's going on here? Along this top row, they only had a 1 in, this has an x in common. And here this has a 2x in common. Alright, so this trinomial factors to x plus 1 times 2x plus 1. This one equation splits into two equations via zero coefficient theorem, or zero product theorem. And so x either equals negative 1, and here in 2 steps, if you subtract 1 and divide by 2, and since these exponential equations, I don't have to worry about extraneous solutions. If I haven't made a mistake, those are my two answers. Alright, so hey, that was the last one. Hope that helps, and I'll talk to you later.